In the previous video, we talked about the null hypothesis. We will continue in this video with p-value. A p-value is a number that helps us decide whether the evidence we have is strong enough to challenge a default assumption, also known as the null hypothesis. Think of it like this. The null hypothesis says nothing special is happening. The p-value is a way of asking, if nothing special were happening, how surprising would our data be? Here's where people get tripped up. A p-value is not the probability that the null hypothesis is true. It doesn't tell you the chance that your results are random or the likelihood that your hypothesis is correct. Instead, it's about the probability of observing data as extreme as yours, or even more extreme if the null hypothesis were actually true. For example, imagine a researcher is curious about whether listening to classical music before an exam can actually improve test performance. The null hypothesis here is that music has no effect. Students who listen to classical music should, on average, perform the same as students who don't. One group of students listens to Mozart for 10 minutes before taking a test, while another group sits in silence. When the scores come in, the music group scores a little higher, maybe by a few points. But the big question is, could that difference just be due to chance? Researchers often use a cutoff, typically 0.05, to decide what counts as statistically significant. If the p-value is less than 0.05, they might say the results are significant and reject the null hypothesis. If it's higher, they may fail to reject it, but this threshold isn't a magical line in the sand. A p-value of 0.049 isn't dramatically different from 0.051, even though one is technically significant and the other is not. Back to our example, the researcher runs the analysis and gets a p-value of 0.03. That means that if the null hypothesis were true, if music really had no effect at all, there would only be about a 3% chance of seeing results as extreme as these, or more extreme, just by random variation. Now, because 0.03 is lower than the common cutoff of 0.05, the researcher might say the results are statistically significant and that classical music appears to help. But again, the p-value doesn't prove the effect is real. It just suggests that the observed difference is unlikely to be explained by chance alone. It's also important to remember that p-values don't measure the size or importance of an effect. You could have a tiny effect that shows up as significant in a very large study, or a meaningful effect that doesn't quite reach significance in a smaller study. Context always matters, so when you see headlines that say, "New study proves music boosts intelligence," remember what's really going on. The p-value isn't proof, it's a clue, one that needs to be combined with other evidence before we can make big claims.